Hey y'all, how's it going? Wait for the camera. I'm here today with some snacks and eltordev. Where are we calling him from today? Do we have a location or is it an undisclosed location?
Undisclosed, off the slopes, maybe at Jackson Hole.
Jackson Hole, alright. So we're hanging out in Jackson Hole this week.
Yeah, hanging out with Jerome Powell.
Why are we hanging out with Jerome Powell?
We're not doing that.
But we're hanging out. We're here to talk about a project that you're working on.
Ginger.
That's my dog. She's hanging out also with us. But we're talking about, so you're eltordev. Why are you called eltordev?
So I'm working on a project called Eltor. And if you're not familiar with it, I did a really comprehensive talk about it at bitcoinplus in Riga, the conference that Nifty just hosted.
2 weeks ago.
2 weeks ago. So check that video. I go through the protocol, what it does. But at the end of the day, Tor, in my opinion, is core infrastructure for Bitcoin, for privacy and anonymity. And if you've ever tried to use Tor before, it might be slow. You might have experienced issues with it. I've talked to several people. Some of them, Michael from Bolts, they used to use Tor for submarine swaps, but they had to stop using it because it just wasn't reliable enough for their submarine swaps. So basically, I'm trying to solve the problem of how do we speed it up.
How do we make Tor more faster? How do we make it more reliable? All of the above?
Yeah, all of the above. So if you're not familiar with how Tor works...
Yeah, what is Tor? Not to be obtuse.
Tor is the Onion router. So if you haven't heard of the Onion router, today it's mainly used by maybe like a refugee or somebody who needs anonymity to get on the internet. Journalists use it a lot in foreign countries where...
Oh, I didn't know that.
Potentially, yeah.
I didn't know that. Okay. So journalists use it in foreign countries to send, communicate back, and people not be able to trace them where they are. Right? Yeah,
exactly. So you do it for anonymity, right? It's not totally private or secure, but it provides decent anonymity because you have a 3-hop circuit. So if I go to a website, I go through an entry, a middle, and then an exit, and then I get the website. If you're going to go to a hidden service, it's actually 2 circuits. Right? The hidden service builds a circuit to a rendezvous point. You meet them at the rendezvous point, and both the client and the server never know their IP address. So it's a good way to keep anonymity when you're online. And we use it a lot in Bitcoin and Lightning.
Wait, I have a question. Before we get into Bitcoin Lightning stuff, I want to go back to this being anonymous online. Like, why are we not anonymous online when we're not using Tor? Like, what's giving us away, if that makes sense?
Yeah, so most ISPs KYC you, and I've actually learned in some countries. I was actually talking to somebody in the Riga conference, who had a German ISP, and the state actually owns all the ISPs in Germany. I didn't know that, which is crazy.
Oh, that is crazy.
Yeah,
okay.
And there's other parts of the world, like in America, when you join an ISP, a lot of the times you have to KYC yourself. You give your social security number, so you dox yourself.
That's for credit check, right?
Yeah, sure.
Okay, wait, hang on. But just because, we're using this term ISP, that's like Internet Service Provider.
Yeah, right? So your Comcast, your Google Fiber, whatever.
Okay.
But what I...
So the person you're paying, the company you're paying for internet connection is the ISP.
Yeah.
And when you connect with them, they give you an IP address, right?
Yes.
So they, a number, specifically identifies you as a customer.
Yeah, so if you go to any website, let's say you go to google.com, they have your IP address, and if the state wants to do a check on you, they can go to Google and be like, hey, who went to this website on this day? Oh, is this IP address?
Got it.
They can go back to your ISP if they have certain, court orders. There's still rule of law most of the time.
We like to think, yeah.
FISA courts and stuff, but
got it.
Most of the time, if they want to get who went to that website, the ISP would have to then give that information, like, oh, this is the person who pays the bill. Here's their identity. Go talk to them if you need to know whatever information about that.
But someone has your billing address, right? And your...
Yeah, usually ISP does.
Maybe your social security number.
I mean, there are... So when I was talking to the guy in Riga about German ISPs are owned by the state.
Yeah.
In America, it's a little bit different. You can actually start your own ISP. Actually, years ago, I lived in the middle of nowhere. and we only had, this was before 3G, we only had wireless broadband, WISP it was called, wireless ISP, and it was over radio waves, and I was just out of range of the nearest WISP provider. So, and there was an AT&T closet about a mile away from me, so I'm like, hey, maybe I can get a T1 line, and I can provide internet to my neighborhood. So at that point, in America, you can still have your own private small ISP. So at that point, if I started an ISP, I would provide the last mile, right?
Oh, got it. Okay.
So I would tap into, let's say, AT&T closet a mile away. I would put up a wireless repeater, and then I'd do WISP to my neighborhood, and then I would provide service to my neighborhood. And there's nothing in the Constitution that says you have to like KYC your neighborhood, right? It's just like a business policy that most people do, and
because they want to be able to bill you, right?
Yeah, exactly. So
like,
I mean,
because if one person comes online and uses too many resources, you need to know who it is to cut them off. Maybe, I don't know.
Yeah, I mean, I don't know why a lot of the ISPs KYC you to use the network, but really you don't need to. You can start your own ISPs. Obviously, we have more options now with Starlink. You're not just linked into like your local Comcast or Google Fiber, whoever provides it in your neighborhood. I mean, there's I know you did a talk with Tollgate.
Yeah, at the conference, and they're doing you can turn your local router into thing you can pay per use.
And really, that's just a version of having a bunch of little ISPs, right? So you could go to a neighborhood, essentially, and you could have 100 people being in ISPs. I mean, they have the last mile connection with Google Fiber or Comcast or whatever, and then you're doing, for that protocol, you're using eCash to get internet access.
For Tollgate's protocol.
Yeah. So Tollgate, in my opinion, is just little local ISPs.
Yeah. I want to set one up at my office.
Yeah, that'd be
back
cool.
in Texas. That would be cool. Okay, so Tor helps us get away from this problem other than running your ISP. So, not everyone's going to run their own as ISP. Yep. Most people have to pay an ISP provider to get on the internet.
Yeah. So I guess, let's talk about what options we have now. So let's assume Tor doesn't exist yet. So the next option everyone says is VPN. Use a VPN.
Okay.
Virtual
private network.
Yeah, everyone on
VPN.
Instagram or YouTube is sponsored by whatever, the ExpressVPN, NordVPN, Molvad.
Yeah, that's right. Molvad's
They have so much money.
Proton VPN has one now too, yeah.
But really that just outsources the trust, right? It outsources it from your ISP. You're just one hop away. Now you're trusting your VPN provider.
So you basically get an encrypted connection from your computer to the VPN provider's computers, right?
Yep.
And then you send all your traffic to them, and then they send it out to the wider internet.
And I mean, that helps in the sense where if you were to visit a website like Facebook or whatever, it makes everyone look like they're using that same IP address, like 100, 200 different people.
Got it.
So there are some benefits to it, but...
like hiding in the crowd.
Yeah, it still doesn't protect you against a state attack, because instead of going to the ISP, they go to the VPN provider and say, hey, somebody did something we didn't like at this time, at this IP address, tell me who it was, go to your, even if they say they don't log.
Right.
If you're under a gag order from a state, they might have to provide metadata.
They could be spying on you.
Right, exactly. So you're just one hop away. You're just outsourcing the ISP privacy issue to a VPN privacy issue.
And it's almost like sending it to VPN privacy thing is almost more centralized, right? Like there's, there's only so many VPN providers.
Oh, yeah. And a lot of websites don't work with VPNs because they're pretty well indexed. There's an IP range for Molvad, and all the websites know it.
Oh.
And the website can say, hey, I don't allow VPN access to my website. A lot of them have a decent reason to do it. If you're running a rewards program and you want to have unique residential IP addresses, you're like, hey, I need to kind of soft KYC you for this reward. Use a residential IP address to get this reward.
Yeah. I feel like if you start running, as soon as you want to start giving people money or handing out resources based on whatever, all of a sudden you need KYC, you need anti-civil.
It's hard.
It's a tough problem. Giving money away is hard.
Giving away free money and proving identity without KYC it's very hard problem.
Yeah, it's a hard thing.
Yes, I mean, so if you go one hop past that, so we're past VPNs.
Okay.
So there's newer technology which I like. It's a step in the right direction. Is Obscura. right? So Carl Dong runs the company called
he was a core dev.
Yeah, Bitcoin core dev.
Yeah.
Like awesome content. Like I've seen a bunch of his YouTube videos. Very personal guy.
Yeah, he's great.
And he's got kind of a 2-hop VPN, right? So you do basically an encrypted, obfuscated WireGuard connection to Obscura.
Yeah.
And then Obscura has a WireGuard connection to a second hop, which is Molvad is their partner right now. So this helps with privacy because Obscura doesn't know what websites you're going to, and Molvad doesn't know your IP address.
Got it.
So it's kind of like a 2-hop Tor circuit. You've got an entry relay, which is Obscura, and an exit relay, which is Molvad. So that helps a lot, but it still has some issues. If a state really wanted to go after you, they would subpoena Molvad, and Molvad would say, hey, the traffic was coming from Obscura, and Obscura would say, we don't log, but then they could potentially get a gag order and then have to maybe turn over metadata. So there's still some state issues there, but it's a great option for normal daily use.
But maybe one of the problems is they're really, at the end of the day, relying on centralized entities, right?
Exactly, businesses run these servers.
Yeah. Businesses have names, they have addresses, they have tax IDs,
they're people.
they have
So then that naturally takes us to the Tor network.
Tor.
It's instead of a 2-hop circuit like Obscura, it's a 3-hop circuit for ClearNet. A little bit different for onion services. We'll get. I think we got into that earlier. But,
we did, yeah.
But yeah, at this point, it's volunteers running these relays in between the entry, exit, and middle. So at least it helps with state attacks. There needs to be a lot of collusion with ISPs and essentially like a 51% attack on the relays in the network to get you.
Yeah.
But you're relying on just the anonymity of a lot of different volunteers running these relays. So if a state wanted to go after you, they could only see like the exit relay, and they'd have to go to the exit and be like, hey, who was the hop before you? And they'd be like, oh, it was this middle. And maybe this middle is in a country that they don't cooperate with. Maybe it's a Russian.
I see.
Maybe it's a middle relay in Russia, and the exit is in America, and they're like, hey, we just don't share data. Like, yeah, go fuck off.
So basically, you're trying to hide in this network of people that are passaging your messages or your data from one node to the next, and so all those little hops in the middle make it so that it's hard to trace back to where it originated and where it's going, right?
Yeah, and a lot of the security in Tor comes at the entry guard.
Got it.
So typically in Tor, that's the most crucial aspect to keep secure is the entry guard, because the entry guard is the one that knows your home IP address, or if you're really trying to be a NIM online, you're probably using like a Starbucks or like a local coffee shop or a toll gate as your entry IP address. But that's the one that you really did. Crucial is to make sure they're not compromised with the exit, because if the exit is colluding with the entry, they can do a lot of correlation attacks.
Oh, got it. Okay.
So that kind of leads to not really issues with Tor, just a fact of Tor is the relay operators don't get paid. They're all volunteers.
Right.
And that can lead to, potential state collusion attacks. But even more pragmatically is it could just slow down because there's not enough bandwidth it's a tragedy to the commons at that point, right? Classical problem.
Yeah, going back to the thing where you hand out stuff for free. Wait, okay, so you need more nodes on the network that have bandwidth that can route these things. I'm a big fan of Tor, but I don't run a node.
Yeah.
I don't run a
you don't run a relay?
Yeah, I don't run a relay.
Yeah, you use it sometimes probably, or maybe your core Lightning node connects to other nodes.
Exactly. I have it running on my server, but it's only an endpoint.
Yeah. I mean, it takes a lot of altruism to run a relay. It's fairly easy, but I mean, again, it takes some effort. You got to make sure it's up. You got to run a server. If you're running it at home, there's some port forwarding or some firewalls you need to poke through, like a little bit of technical issues.
Is there any risk with running a node, like a Tor node?
Not as much as if you're middle or entry. There's a little more risk if you're an exit relay, because you're the IP address that the website sees to. So if you go to a website a state doesn't want you to see, potentially your IP address could get flagged and somebody could come knock on your door. But there's precedent set with the Tor project, and they actually have like a stock form you can fill out that goes to like the EFF, and they'll like give somebody to on your behalf.
Oh, okay.
Give the legal law whatever to the country to be like, hey, like they can do this. They're encrypted. They don't see what it is. They were just hosting a Tor relay. This is actually like blessed data. It can go through. So there's ways even as an exit to have like legal protections.
Oh, okay. But yeah, it's interesting that you need legal protections. But yeah, so like the traffic coming out of the exit node is all encrypted, and the only person I don't think it's encrypted when you pass the exit.
Yeah, no, I mean it's at that point it's like you know what website it's going
you know
to.
Where it's going.
Yeah, it's SSL encrypted, so you don't know what's in the body.
Right,
you know, like the header data, like the
but
website.
You know where it's headed.
Yeah, you know where it's going, and that would bring us to hidden services. At that point, so if you did not want the exit to know where you're going, you don't use an exit. You use hidden service.
Oh, okay. That's cool.
And that's what, out of the box, if you've ever ran Umbrel or Start9,
yeah.
Tor is enabled by default. Your Start9 node, you can actually NAT punch into your home network through Tor, which is a lot of people literally used it for that.
Mm-hmm.
They didn't punch SSH tunnels into their home network. They just used Tor as a home tunneling tool.
Basically. Because one of the problems of running a server at home is that you don't have a public IP address.
Yeah.
So if you're running a service or like have a website, you can't like point a domain name at your IP address.
And a lot of ISPs, your IP address is semi-static. Like it doesn't change. If your router's down for a couple days, you might get a new one. But the IP address at like my home I've had for 3 years. Like it hasn't changed. I haven't rebooted my router. So you can semi-statically do this, but it takes technical knowledge to go to your router, do port forwarding over, let's say, 22, to get to, then do NAT forwarding to wherever your server's at on your home LAN. So, a lot of people don't have that technical knowledge, so they use Tor hidden services to tunnel NAT punch into their home servers. That's a tech.
Yeah, that makes sense. Okay, so a lot of people are using Tor, especially Bitcoiners, to get data about Lightning payments. Like maybe they're writing Lightning information over it. Maybe they're like loading blocks out of it. Like, what was the project that you started a project called eltor?
Yes.
And then what's like the goal of the project? Like Tor, you're not making a new network. You're not like making a new protocol. Or are you? What are you doing there?
Well, we can get into a lot of details on why it's a fork. Does it have to be a fork? Can we just put the code into normal Tor and have people run it?
But what are you doing at like surface level? Like you're taking Tor and you're adding something to it, right?
Yeah. So it's Lightning, right? So Lightning is.
But Lightning's like you're just adding Lightning because you want people to be able to get paid, right?
Yeah. So it goes back to the incentive problem. Okay. So the incentives of Tor. So there's a really good metrics website. I think it's tor.metrics.org. And it shows you over the years how many relays have joined the network and what is the bandwidth, the total bandwidth of the entire network. You can compare that to another metrics. I think Mempool has a really good Lightning metrics explorer over the years. And if you overlay the two networks as they've grown, you can make a strong correlation that in the year, I had a slide in the presentation at the Riga conference. WTF happened in 2022. Like what the F happened in 2022 with the Tor network? Because if anyone remembers, in 2022, the Tor network was slow. Everyone's like, it's getting DDoS. Why is it?
Yeah, I remember that.
Yeah, why is it so slow? Like Tor sucks. And a lot of people are just like, Tor sucks, and they wrote it off. But what I think happened is Umbrel and Start9 got really good.
And those are basically like node in a box.
Yeah,
right?
Node in a box. So a lot of people were into Bitcoin, but they never ran their own Bitcoin core node.
Right.
Because it was just too hard. They had to have a laptop all the time. So once it was really easy, like Casa tried to do it in 2019, but they discontinued that product. But Umbrel and Start9 picked up the slack from there. And then 2021, Maulers went on stage and said, Lightning in El Salvador, and everyone got really stoked about Lightning.
Yeah, that's right.
So in 2022, what happened is everybody downloaded Umbrel and Start9, and it was the first Bitcoin core node they ever ran. And I think the Bitcoin blocks, I think it was 600 or 700 gigabytes.
Yeah, that sounds about right.
And by default, Umbrel and Start9 ran behind Tor hidden services by default.
Okay.
On Umbrel, you couldn't even turn it off. You had to communicate with your peers over Tor.
So you would buy a start. Basically, what you're saying is people were buying these Start9 nodes, taking
Yep.
them home, plugging it in. It's gonna first thing it's gonna do is initial block download, right?
Yep.
Which is basically
BD.
like 700 gigabytes of data that it's pulling to itself over, and every packet,
And it was configured by default to use
Tor. So every packet that it received and sent was over the Tor network.
Yeah. So to go back to that graph, if you look at the graph of what happened in 2022, is we had about 8,000 Lightning nodes in 2022 at the beginning of the year.
Yeah.
At the end of the year, we had 18,000.
Oh, wow.
So what happened is everyone spun up these nodes Tor only, and the network wasn't getting DDoSed. It was getting used by Bitcoin and Lightning users. To use a Lightning node, the prerequisite is an entire block download. Yeah.
You need a Bitcoin core node to be fully self-sovereign on Lightning. You need access to block.
And I've watched a couple of videos during that era of the head developer Roger Dingledine of Tor project.
Yeah,
he's like, he's like, who are these Bitcoin users using Tor? Like who by default said to use Tor onion services? And it's like, oh, I mean, Start9 and Umbrel, like and we're most of us are privacy focused, but a lot of it was pragmatism. Mm-hmm. We have to NAT into our home routers remotely. We have to use Tor hidden services. So I mean that's the story of why Tor was slow in 2022.
Is Lightning took off.
Lightning. Yeah. So Lightning was a huge success. 2022 was the year Lightning, I think, just exploded. Yeah.
Yeah. I mean, that part of that was PlebNet, right? And everyone was at home during the pandemic.
Oh yeah. They were bored at home, spinning up home servers and getting really nerdy. Like, yeah, we all did it. Like, it was fun. It's how it should be. It's decentralized. When everyone's running servers at home and commuting through Tor and remoting in their servers, that is decentralized.
Yeah, definitely.
So I mean, that kind of leads us to what the problem was. Like, not enough relay operators spun up. A lot of clients spun up. And there's actually another chart of the Tor onion service bandwidth, the total bandwidth of the Tor network.
Yeah.
So pre-2022, it was 10 gigabits per second. Once 2022 hit, it went to 50 megabit per second. So it 5x'd in that short amount of time.
Got it.
So typically on the Tor network, you get a spike in bandwidth. Tor goes out to like their sponsors and, hey, we need more relays in the network. They have a lot of nonprofits and just individuals, and they say, hey, we need more relays. Maybe somebody will donate $1 million.
Got it.
And then you'll get 500 more relays pop up with more bandwidth. But this happened in such a short amount of time in 2022, we weren't able to fulfill that need out of volunteerism.
Oh, got it.
So that kind of led me to my conclusion of, maybe we should start paying some relay operators.
Oh, you're like, so what if you made it a paid position instead of a volunteer one?
And it doesn't have to be. I mean, you could set your rate to 0 sats and still do volunteerism, which is great.
Charity work is still accessible.
Yeah, but I basically came to the conclusion of, also the Tor metrics website, you can query all the relays. There's about 8,500 relays on Tor.
Okay.
You can go to the search field and you can do a straight up search. So I'm like, I wonder how many people, because I knew people would put Bitcoin addresses in their contact field. Basically, hey, donate to this Bitcoin address. I'm running a relay.
Okay.
Like if you want to support the cause. So I went to it, and how many out of 8,000 relays, how many people do you think had a Bitcoin address in their contact field?
I'm going to say 10%, like 800.
Close, yeah, it was 1,000. Okay. Over 1,000 people had a Bitcoin address. So I'm like,
over 12% of the network.
Yeah, so the relay operators are already at a point where like, hey, like we like Bitcoin. Donate if you like the work we're doing. Operating these relays, donate to us.
Right, to help us keep them online.
Yeah. So I'm like, why don't we build that into the protocol, like to incentivize? Because that's volunteerism. Maybe you don't get paid this month.
Right.
Maybe you do get paid. And then at that point, it was around the time Bolt 12 was starting to get popular, specifically blinded paths to give receiver-side privacy. Because if you're going to be a relay receiving payments for your service, I would like that. You could have some privacy on the receiver side so somebody can't trace it back to you.
Got it.
Blinded paths work a lot like how onion services work in Tor.
They do, yeah.
There's a great talk at your last Riga conference by T. Knoll from Spiral.
Yeah.
He did a good talk about how blinded paths work and just the state of privacy and Lightning, I believe is what his keynote was.
It was, yeah, he gave a keynote.
And that was really good. And a lot of that tech I wanted to utilize in Tor. But, you know, to misconception, I'm not using the Lightning network to route data packets. I'm not doing TCP routing through Lightning like that. It's not the same kind of network.
So what are you doing?
So basically, I took Tor, and anytime you build a 3 or 6 hop circuit, there's a handshake that happens beforehand.
Okay.
Of this onion sphinx that gets wrapped up to each relay.
Right.
And you can pack a little bit of data in each of those hops.
Mm-hmm.
So essentially, I go to the directory authority and I download a descriptor that says, hey, this relay wants to get paid at this Lightning offer, this Bolt 12 offer.
You're using, okay.
Yeah, and much like your liquidity ads, you can set your rate.
Right.
Right, similar idea, similar
cool.
concept. You tell the network, this is the rate I charge if you want to
You're pricing bandwidth, though, not like access to liquidity.
Yeah. I'm pricing a 10-minute. It's basically the price per minute for a 10-minute circuit.
Okay.
And then pay this Bolt 12 offer. We use payment hashes and pre-image to kind of like check if, as a receipt, if you actually paid or not.
Yeah.
So in that circuit handshake, we pack all that data into it. The relay operators get that data, and they know the circuit ID, and then there's 10 rounds, right? So the first round, I get paid. I go to my Lightning node. I say, oh, this payment hash came through. Yep, this is somebody where he's allowed to go through. Second round, oh, this payment hash went through. I go to my Lightning database. I check that it's mine. Yep, he can go through.
Got it.
If round 3, I don't get paid for like that minute interval, there's no payment hash that comes through my Lightning node, I kill the circuit.
Got it.
And that's if you set a rate. You don't have to set a rate. Your rate could be 0 cents per minute, and you can just allow people to route freely through it.
Right.
So it could be backwards compatible with the way Tor exists today, but I mean there's a reason it's a fork right now, and I can get into that if you want.
It's a fork of
Tor.
So you took Tor and you forked it. Yeah.
So Tor allows you to. They have this network called Chutney. So you can run your entire, much like how Bitcoin, we can run reg test. It's essentially a local network you can run, but you can run that in the cloud too. So the reason it's a fork right now is because I have to add extra data to that circuit build step, right? I have all those payment hashes that need to be in that Sphinx message beforehand.
Yeah.
And that increases the data size. So it's just over the size that a Tor relay would accept. It's, whatever, 2,000 bytes over or whatever. So right now it's a fork, and I don't think the Tor developers love the fact that relay operators get paid. They're like, Tor relay operators are volunteers. If you start paying them, there's some videos of the Tor project. They don't love the idea of that kind of capitalism.
Oh, I see. Interesting.
So it's probably going to have to be a fork, unfortunately.
What do you mean? So it has to be a fork in it, but it interoperates with Tor network, right?
I mean, it uses all the same code. It's like 2,000 or 3,000 lines of code.
But if I'm sending messages from my eltor node, it can route through the rest of the Tor network.
No, because the circuit build has a bigger header size.
Oh, yeah. So it is a fork.
Yeah,
okay.
It is a fork because they just can't pack those payment hashes in there.
Oh, so you did have to.
I'm over the size. So basically, if I tried to send a payload to a Tor relay, they would reject it because they're like, hey, that header size is too big.
Can you like chop off some of the bytes on the hash?
We should talk if there's some clever way you can think to do it, but there's just not enough padding in that headers to add payment data.
Got it.
Yeah,
okay.
Because again, the goal is the relay, like the exit relay, can never know the IP address of the client relay.
Right.
So they have to communicate through the Sphinx message, the onion message between hops. So I have to pack extra data into each hop. And the way Tor
is... The frame size is
the frame size is not big enough for these payment hashes.
Which are 32 bytes.
Yeah, and there's no way to compress it because, a 32-byte hash, you can base 58 it and get it down a little more, but it's just, I need the payment hash to check against my Lightning database.
Got it.
So
you can't do like the first 16 bytes?
I don't know. You tell me, Lightning dev.
You might be. I mean, it's like okay, we can talk about that later, but yeah. I mean, I guess the real question is how many bytes do you have? You don't have 32 bytes.
I mean, it's 10 payment hashes, so it's a big string.
Oh, got it.
It's 10 times 3.
It's 320 bytes.
Yeah.
Okay.
I mean, it's extra. It's a lot of extra data.
It's extra data.
And in the Tor network, you don't want to stick out. You don't want to fingerprint yourself.
Right.
All the data is padded, so there is a little extra data, but it's not 320 extra bits of data. So.
Yeah, I'm slightly familiar with that because Lightning Network uses Onion messages, very similar construction.
Yeah.
I haven't looked at how Tor does it.
Yeah, I mean, we should look into it because I mean, if it's possible to fork this into the existing Tor network, that'd be awesome.
Yeah.
To have the anonymity set of Tor as it exists, but I mean, just with the way, I mean, you just need. I mean, the way I architected it was 10 rounds of. Every minute you get a payment hash you have to verify.
Got it.
I mean, you could have more trust assumptions where I just won, but then it's like there's a lot of attacks you can do with just sending one payment hash for 10 minutes of data. Maybe it'll be bigger and maybe you don't provide me service. There's a lot of Sybil attacks that you kind of get into if you don't chunk it up into tiny little rounds.
You like the idea of it being per minute.
Yeah, so.
Interesting.
Yeah. And there's a way, so if it is a fork, you know, you start off, you bootstrap the network, eltor. There's a smaller anonymity set at first, but, I mean, look at the Lightning Network. We have 18,000 Lightning nodes.
That's right.
Look at Tor Network.
So you're saying if every Lightning
we have 8,000 Tor nodes. So I'm like, we already have a huge set, more people running Lightning nodes than Tor relays.
So you're like, if every Lightning node was running an eltor relay.
And you can get paid.
It would double the size of the existing Tor network.
Yeah, and that's why I'm kind of bullish on, like, if it does have to be a fork, there's 18,000 people running nodes, and this could be a way, it's not yield, but it's a way you have an always-on server that you're not using all that bandwidth, most likely. This could be a way to supplement running your own node at home. So potentially we could get more home runners.
More home runners. Let's go.
Or even if you're running in the cloud, like.
Are you like packaging? So I mean, then you start getting into like, okay, so you've built this. Like, what state is the project at now? Is it like built, ships, ready to run? Like you're still.
Yeah, so I have the Chutney testnet running on a public cloud. So that's the directory authority code. I have a eltor binary. So much like the Tor binary, you can configure it, run it, set a configuration to go to your core Lightning or Phoenix are the two implementations I support right now.
Very cool.
Just because of Bolt 12 offers.
Yeah.
I potentially will do Bolt 11 blinded paths. I know LND supports it. I mean, I do want to put privacy first on the receiver side, so blinded paths is like I want it to be. Maybe I'll do a Nostr wallet connect or this type of stuff that has less privacy on the receiver side.
Got it.
But I want to start it off, you know, with privacy in mind for the receiver. So yeah, I've got a daemon out there you can run, get started at home, start getting paid to do your bandwidth. On the roadmap, I went through, you know, the talk at Riga. I have this roadmap slide. I do have an Umbrel app coming, hopefully next month.
Cool. Okay.
The idea is for a relay operator. You're at home. You have an Umbrel node. You click one button. It auto connects to your core Lightning node.
Yeah.
Grabs a Bolt 12 offer through their API. Sets up an eltor node. Spins it up. It puts the descriptor out on the directory authority of your Bolt 12 offer. You set your rate, let's say 1 cent per minute.
Okay.
And then you're off to the races. You just start getting your Umbrel node just starts getting paid.
That's cool.
For having internet access.
That's really cool. And anyone with an Umbrel node could like do that. And but it's not even you're getting paid. I mean, you're also helping people who want to. You're like contributing to the anonymity set.
Yeah, and you're helping yourself because you're probably using Tor yourself to secure your own Lightning node and your Bitcoin node, and I mean, we're not. I think a lot of people think we're at the, you know, the thing like they will fight you, then they join you, then you win.
Right.
I don't think we've hit the they will fight you stage yet. A lot of people are like, oh, the government loves Bitcoin. It's like, no, we have not hit they will fight you stage. And when we hit the they will fight you stage, I mean, I'm hoping everyone is running their Bitcoin and Lightning node behind Tor, because if they fight you, they can do a lot of analysis on transactions and who's gossiping to who. Chain analysis is just a big mess if you're not using Tor. Like, you're really doxing a lot of data. So.
Right. Okay, that makes sense. Because it's like your IP address, where you're connecting from,
Yeah.
MAC address.
I mean, your peers, 7 of your 8 peers are probably chain analysis, right? So you don't want to give them your home address, right? And today, Umbrel, I believe Start 9 in their new release, offers 1 degree of separation. If you're not using Tor, you can use a Cloudflare IP address. Okay. So you can have a Cloudflare tunnel. But again, you're just 1 hop away, because on Cloudflare, I had to pay with a credit card.
Oh.
So that it's just 1 hop away from my IP address. So it takes the state 1 hop to know who I am. So I mean, it's not a great solution.
Right.
Yeah, I mean, you're going to want to have Tor. I mean, I2P is another network. I haven't dug down deep into that. It's way smaller. I think my Bitcoin Core mode might have 1 I2P peer. I mean, it's not as used.
I don't know what it is.
Yeah.
It's cool.
I know John Attack has done some talks on it. I think it's kind of mixnetty, like some of the stuff I think Claudia is doing, maybe similar to that.
Yeah, Claudia came to talk from NIM Networks.
Yeah.
Or NIM Technologies, I think.
Yep.
It's cool. So what's next for you? So you're shipping this Umbrel app.
Yep.
You've got a working client. You've got a test network set up.
Yeah, so then after that, a VPN-like client. So kind of like Obscura, you can like download this client, you connect it to a Lightning node, and then you can, as a client, you can activate it. And at that point, it's a SOCKS 5 proxy.
Okay.
Right. So a SOCKS 5 proxy can be ran in the web browser. So then you can connect it to like a Firefox or Chrome. And I believe some operating systems allow you to tunnel all traffic through a SOCKS 5.
Oh, that's cool.
It's TCP traffic. It's no UDP. So I mean, it could be. You're probably not going to use it for gaming. Like if you're doing gaming, use Obscura. They're going to have much lower latency because they use UDP and all these.
Oh, interesting.
But Tor has fairly low latency. It's going to allow you to do Bitcoin stuff, Lightning stuff, streaming videos, all that stuff. Fairly low latency, 100 or 200 milliseconds. Yeah. So I mean, the idea is to hopefully just get friends using it now.
So now you're trying to grow the network.
Yeah, so right now it's bootstrapping the network. I would like to pick your brain. Can we compress the data in a Tor header cell to see if we can shove these payment hashes in there?
Yeah.
I don't know. I don't think it's possible, but if it is, that'd be awesome. If not, I'm kind of okay with forking the network because I just know Lightning node operators are awesome. And there's over 18,000 of us known. There's not... I mean, there's a lot of unannounced channels, right? There's a lot of us. You get it. Don't be bearish on Lightning. Lightning is the backbone of the decentralized internet. I'll make that strong statement right here, right now.
I mean, that's cool. Like, the project you're doing is basically making it such that, like, Lightning becomes the backbone of getting paid to run servers on the internet. Right? Like,
yeah, and I'm bullish on, like, Tollgate, too. Like, what if what if Bitcoiners become, what if there's a billion ISPs? Right, even look at BitChat, like Bluetoothing data and mesh networks. I mean, as Bitcoiners get wealthier, maybe one of them launches a rocket and puts a satellite, and we have a Bitcoin Starlink.
Oh wow! Yeah.
Yeah, I mean, there's a lot of options at the ISP layer, but I mean, for now, keeping our boots on the ground. I mean, we can build our own little Tor network as Bitcoiners.
That's cool. Yeah. So bootstrapping Bitcoin Tor for Bitcoin.
Yeah.
That's cool.
Yeah, and I mean, during the bootstrapping phase, again, if you want to protect your anonymity, run an entry guard. Like go out to Lunar Node, pay in Lightning, spin up an eltor entry guard, and then have your client at home connect. You can set in the configuration to set to your entry guard. And at that point, even if there's only 10 people on the network, they're not going to be able to correlate to your home IP address because you're running the entry guard. Okay. So there are ways to safely bootstrap this network when your anonymity set is fairly small. So yeah, I think at this point it's just a matter of making it easy to use, one click. Nobody will use your software until it's one click, even your best friends who are technical. So
it's kind of true.
Yeah, I mean, you got to make it one click. And,
yeah, I was gonna say, like, if I've got a Lightning node running on NixOS or something like that, is it like, do you have like a NixOS package for it, or is it like?
Not yet, but I've been starting to mess around with Nix Flakes, and I'm brand new into Nix, but I'm a big fan, and I've created a few ways to build the application in Nix as opposed to like a GitHub Actions or something.
Yeah, exactly.
So it's getting there.
Yeah, I should build like a Nix module.
Yeah.
That anyone who's running it can.
We'll get a base 58 Eltor relay running.
Yeah,
out there.
exactly.
Yeah.
I don't think I put my name on it though. I feel like that ruins the idea of like anonymity, right? Like,
It'll just be a nim node.
yeah, name node. It's cool. Cool. Was there anything else? eltordev, if people want to get involved with the project, follow you on the internet.
Yeah, there's. I mean, the best way is on GitHub. It's github.com/el-tor. I believe I have a Twitter. I think it's just eltordev on Twitter. Those are the best places. Base 58 conferences. bitcoinpluses. I tend to frequent those, so I'm just fine.
Yeah, you were in Riga.
Just find me. I was in Riga.
We got more conferences coming up. We'll be in Canada.
Yeah.
I don't know if it's officially announced yet. We're planning on being in Canada in July next year.
Yeah.
That's an insider edition alpha right there.
Yeah, I'm ready
be in Taipei.
Ready for Canada.
Taipei and what do you call it? We'll be in Taipei talking about sovereignty in December.
Wow. When Antarctica?
No plans yet, but the joke that we've been passing around is like we could do a cruise to Antarctica.
Oh, Bitcoin plus cruise edition.
Yeah, we're gonna make it cold storage edition.
Oh, yes.
And then the joke will be like it's a boat accident waiting to happen.
Well, you've been to North America, South America,
Yeah.
Europe, 3 continents, and
Europe and Asia. I guess Istanbul kind of counts. I haven't been to Australia.
I mean, that one's easy with Rusty out there.
Rusty's out there. There's a bunch of really great devs out in Australia.
So Australia is probably your.
I could do that.
If you hit all 7 continents, like that's kind of like you are the most global. You're already at 4 or 5.
We're already at 4 or 5, which is I think a few more than most people.
Wow.
Yeah.
Goals.
Yeah. Anyways, yeah. It's great chatting. Is there anything else you want to viewers should know? Are we like?
No. Yeah, I'm grateful for your conference, and yeah, keep up the good work, and you bring the crazy people together to build crazy stuff. So yeah.
Yeah, cool. And your talk should be online soon if it's not already. So.
Yeah, check out the talk. I go through all those metrics and all the diagrams, and yeah, just step by step. There's like 11 steps to how the protocol works.
Oh, cool.
And it's still new. If you have good ideas of how to compress the data, maybe we can shim it into the normal Tor network. If you're a crazy low-level developer, let me know if you have ideas. We're open to PRs.
Cool.